Hello everyone, we are going to perform an experiment on energy band of a diode. So the objective of the experiment is to determine the energy band gap in a semiconductor by using a junction diode.
Apparatus required are the unit has the following built-in parts: 3 volts fixed DC power supply, moving coil microammeter, electrically heated oven to heat the diode, a sensitive thermometer, and a semiconductor PN junction diode.
Here we are going to introduce what are the required apparatus. So first we need enough circuit, and then we need an voltmeter to read the voltage and the ammeter which we need to use for calculating current because it is very sensitive current and it is in micrometer. And then we need an oven for heating the glass of water so that we can have the diode. It is an diode. And then we have a thermometer for calculating the temperature.
This is the energy band gap apparatus. This is a jumping wire. We will join this jumping wire positive to positive, and then this is a sample diode, and this negative side we will join to positive side of the microampere, and then we will join the positive of the to the microampere of the positive, and then we will join negative of the micro sample diode to the negative of the microampere. Then we will join the positive of the jumping wire to the voltmeter of the positives, and then negative of the voltmeter we will join to the voltmeter of the negative sign. And there this sample diode of the positive jumping wire we will join to the positive side, and this is the diode we will join to this diode of the positive sign, and this negative one will be joined to the sample diode of the negative sign.
Of this experiment, put the oven switch on and position allow the oven temperature increase up to 80 degrees Celsius. It means we have to boil up this water at till 80 degrees Celsius. So first place it over here, turn it on with the bands, and now put up the diode which has been already connected into that water. As you can see, we have put up that diode into that water. Now we have to put this thermometer in it, which will tell us the reading about this experiment. So currently it is at 24.7 degrees Celsius, and now on it will increase due to this oven. As you can see here, the reading is rapidly increasing till 90. So now we have to put off this apparatus. As you can see, we have switched off this, and now we will put this copper vase at the bottom of the table. As now the time has come to take up the reading of this apparatus. After interval of every 5 degrees Celsius, we have to take two readings. First, the reading of this thermometer, and the second reading is micro. As the temperature as you can see, as the temperature drops, the current also decreases with the time and the decrease in temperature. Like as you can see here, the temperature drops to 84 degrees Celsius, as now the reading has become, now the temperature has reached 80 degrees Celsius, and you can see here the current has reached over 1500 microamperes.
Now the next part is calculation part. Plot a graph between 10 to the power 3 upon t on x-axis and log IRS on x-axis and find its slope. The graph will be a straight line. If AC will be the straight line obtained by the actual readings observed in the experiment, then the formula of the energy band gap is equals to slope of line upon 5.036, and here energy band gap is in electron volt, and
So here the calculation part comes. Then as we take the reading of and every interval of 5 degrees Celsius on 85, 80, 75, 70, 65 and so on. And we will calculate in temperature in Kelvin, and we note after on the decrease of temperature the current and voltage. So here the current, and we will calculate the log of I current. After that we will divide the we will multiply the 1 upon t by 10 power 3. So we get this table, observation table, and with this help of observation table we will try to make with this observation table we make a graph with the help of between the log I and 10 power 3 by t. So we get this graph on okay. So after that you can see that on 2.8 the our log I is 5.6, and you can see that we plot the graph. After that we will try to calculate the slope, as we know that the formula of slope y2 minus y1 upon x2 minus x1. So y2 minus y1 is our y2 is AC 5.22 minus 0, and the x2 minus x2 is 3.2 and x1 is 2.8. So we get our 13.05 after calculation slope. Then we will try to calculate the energy difference of energy gap, band gap. So after calculation of slope we will calculate the energy band gap. The formula of energy band gap is slope divided by 5.036, where 5.036 is the constant. So after that we will do some calculation and we will get 2.59 electron volt, because the energy band gap notation is electron volt.